Welcome to the MEC 155 discussion on Unit 15, cams. So there's two different kinds of cams, radial cams, and I'll show you some examples of those here in a little bit, and cylindrical cams. Both of these convert rotational motion into linear motion through a follower. And there's a picture of a cylindrical cam in the book, but basically it's a rotating drum with a track on it, and the follower would follow along in the track, and as the track goes left and right, it would create that linear motion as the cam rotates. I also try to put some example videos online for you as well. So what we mean by this is if we have, let's say, a circle, and there's a follower on that circle, as the circle rotates, the follower would not move up and down. It would just stay at that outside diameter, that base circle, if you will. But if we add some stuff to the base circle in various parts or various regions of what is now becoming a cam, we can create different scenarios where that follower would rise as the cam rotates. So in this region up here, as the follower is on that part of the cam as it's rotating, it would rise. In this region here, it would dwell. It would stay at that 1 inch distance off the base circle. And over here, it would fall back to the base circle. And again, over here, it would dwell in the base circle. Now, to give you an example of what I'm talking about here, I have my grandmother's sewing machine. Well, that doesn't seem very exciting, but in reality, sewing machines are fascinating mechanical marvels. They have so many things going on inside of them, and they're all driven off of one motor. This is a special sewing machine that allows you to create different stitch patterns, and I'll show you that here in a minute. But for those that aren't, super familiar with a sewing machine, when a sewing machine runs, if you watch the needle here, the needle goes up and down, but it's also going left to right. And underneath, there's a bobbin holder. Whoops. And the bobbin holder is also doing some fancy motion. It's not only spinning, this one's actually rocking back and forth, but it's also going side to side to create that stitch pattern. And all of this is run by one motor. There's one motor back here that runs this main wheel, and then all the mechanisms inside. But let me show you this, this fancy stitching that is controlled by cams. So there are various cams that are used with a sewing machine, and they've got different profiles of rising and dwelling and falling, and they go up here. So let's take this one. See if we can get this in here properly. And I switch this over to a straight line and this over to auto. And now what you can see is there's a follower that is riding on the outside of that cam. And as it rotates, okay, so now it's dwelling at the base circle, it's rising, falling, dwelling, rising, falling, dwelling, and it's creating a stitch pattern that's going straight up and down, and then it starts to go side to side, straight up and down, side to side, and it's all controlled by this cam. Now, if I take the top off of this, we get to see all kinds of good stuff. What we will see is, so the main rotation comes from this belt up here that's driven off the motor, and there are all kinds of cams underneath this mechanism right here. There's a cam that as it rotates, it causes that to go back and forth. There's a cam down in there. Let's see if I can get this down in here, that as it rocks, there's a fork that holds a against that cam, and you can see it moving back and forth. And there's all kinds of cams and fascinating rotating parts in here. But here you get a better look of that cam follower. Now this is a very simple cam. We can get something that's a little bit more complex out. Here, let's see what we got. Let's pick this one. This one looks exciting. Never knew sewing was this exciting, did you? I am not a big sewer. My daughter uses the sewing machine more than I do. But she usually sews what I need for various projects. But there you can see some a little bit more elaborate cam action. Now, usually in most cams, you don't want to see a scenario like this. Yeah, this is going to be a little tricky to get on here while I have my hands in here. Let me spin this around just a little bit. I need it a little bit further. I should be able to get it on here. There we go. Usually you don't want a sharp edge like that on your cam profile. But because this is only rotating in one direction, it allows us to have that nice sharp edge so that we can change the motion drastically at a specific point in the rotation. Anyways, that's what we're talking about with the rise, dwell, and fall on a cam profile and what a follower is. Now, when we analyze the motion of any particular cam, we can plot it on a linear graph that shows, the total linear motion at the various angles of rotation. So from 0 to 90 degrees, we might have a rise. And from 90 to 180 degrees, we have a dwell. And from 180 to 270, we have a fall. And then from 270 to 360, we have our final dwell. And it all comes down to how we convert that rotation into a linear motion. So I'll put some more materials on here online for you, but please be sure to let me know if you have any questions. Thanks. See you soon.